So let's say that you're out in the field and you find a metamorphic rock. So what does that metamorphic rock tell you about the environment in which it formed? Well, one thing that you could do is you could analyze the metamorphic rock for the minerals that it contains. And there are certain minerals that only form under certain pressures and temperatures. So if you look at this chart here, notice that the mineral chlorite tends to form under low pressures and low temperatures. On the other hand, let's say that you find in your metamorphic rock muscovite mica. So you'll notice that it forms at a higher pressure and a higher temperature than what chlorite forms at. And then biotite mica forms at an even higher pressure and higher temperature. And then the mineral garnet forms at a higher pressure and higher temperature, so that by the time that you get down there to the bottom, you got sillimanite, and that forms at the highest pressures and temperatures. So when you analyze your rock, you look for certain minerals in it, and then that gives you a range of pressures and temperatures at which that metamorphic rock formed. Now, what about if you find quartz and feldspar in your metamorphic rock? Well, that's not so good, because you notice that quartz and feldspar are found under all sorts of different kinds of pressures and temperatures. Now, you might be able to tell it based on the shape of the crystals. So if the crystals are really flat and oriented, then that would mean that it was under high pressures when it formed. Okay, you could also tell where a metamorphic rock formed based on the what kind of metamorphic rock it is. And so these are going to be called index rocks. And so there are certain kinds of index rocks that form under certain conditions. So the first kind you'll see up there in the chart that is to the left, in the upper left-hand corner, you've got a type of metamorphic rock that's called a zeolite. And in this particular kind of metamorphic rock, it forms under low pressures and low temperatures. And so that is going to be metamorphic rock number 1 in the second picture. So if you look at the second picture, find where there are examples of the number 1. Do you notice that they're very close to the surface? So that would mean that they are under conditions of low pressure and they're under conditions of low temperature. So those would be the environments in a subduction zone where you would find those kinds of metamorphic rocks. Now, on the other hand, look at amphibolite. So amphibolite forms under conditions of higher temperatures and higher pressures. So amphibolite is going to be rock number 6 in the second one. So let's find out where rock number 6 would be. So do you notice that rock number 6 is lower inside the earth than what the zeolite was? And it's going to be under, the deeper it is, the higher the pressure is going to be, and also the deeper it is, the higher the temperature is going to be. So I will let you look at some of those other kinds of metamorphic rocks and where they are found. So the point is that if you find a metamorphic rock, depending on the type of metamorphic rock it is, that's going to tell you where it came from. And then also, depending on the minerals in the metamorphic rock, it's going to tell you the temperature and pressures that it was subjected to. And then we talked about the certain kinds of rocks, like, for example, if you found marble, what would that tell you? It was a contact metamorphism, so that meant that it was in an environment where it was not subjected to pressure, but it was subjected to intense heat. And so we talked about an environment in which that would form. We talked about regional metamorphism, like a gneiss, and we said under what pressures and temperatures would that be metamorphosized into? All right, so here's our summary, and we'll discuss this in our next segment.